Hi there guys, today we'll be talking about in this video the Karnaugh map. I, Harsh Kataria with my team which consists of Shreyas Papanwa, Shishti Kirti, Ahan Goswami and Mrigank Shekhar will talk about K-maps, their simplification and the process. Well, we'll briefly discuss about K-maps. The contents of this presentation and this video will be as follows. It will include the introduction, the visualization of K-maps, its properties, advantages of Karnaugh maps, sum of products and POS, the product of sums, basically the min terms and max terms, and the Karnaugh map construction, simplification process, examples, some don't care conditions, and we'll take into consideration more questions and examples for your knowledge. Well, the introduction. The Karnaugh map is also known as the Veitch diagram or K-map. It was invented in 1953 by Maurice Karnaugh, a graphical way of minimizing or simplifying Boolean expressions. That's what a K-map does. It's a graphical representation of basically the same thing. K-maps are tables of rows and columns with entries represent ones or zeros of SOP and POS representations. An n variable K-map has 2 to the power n cells with each cell corresponding to an n variable truth table value. K-map cells are arranged such that adjacent cells correspond to truth rows that differ in only one bit position. Logical adjacency. The logical adjacency is what's this property called. As you can see here, that's a typical K-map. It's a 4 variable K-map. The variables are A, B, C and D, and you can see these are the CD values, these are the AB values, and since it's a 4 variable K-map, 2 to the power 4 is 16. It has 16 cells which have ones and zeros filled in them. So yeah, again I'll show you what a typical K-map looks like. So it's a table, hence it's a graphical representation. So it's in the form of a table: A, B, C, D. So and we just discussed that it has 1 bit difference in each cell. After each cell, the adjacent cell. So it starts with 0, 0, 0, 1, 1, 1, 1, 0. See, 0, 0, 0, 1, only 1 bit was changed here. Again 1, 1, only 1 bit was changed here. Then 1, 1, 1, 0, this bit was changed here. Same goes for the AB side: 0, 0, 0, 1, 1, 1, 1, 0. Yeah. These can also be said as A, B bar. Well, this is in terms of SOP, since A bar is considered 0 and A is considered as 1 mostly, and this will be A bar B, A, B, A. I'm sorry. So here is A, this B, and well, this is C and D. Yeah, B bar. Yeah, good. This is C bar, D bar, C bar, D, C, D, and C, D bar. Yeah, that's how it goes. And well, you can form a table if you want. It's already in the form of a table, so that's how it will look like. You have to fill in these cells with the SOP or POS values how you please. Well, these values correspond to the truth table. So let's make the truth table a typical truth table just for the 4 variables, and how they correspond to, how the binary values correspond to the decimal values. Yeah. How that goes is, A, B, C, D, and here is the decimal value. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0. Okay, we will be less on the space here, so well, you'll get the idea of it. 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. The decimal values for the 8 of these would be 0, 1, 2, 3, 4, 5, 6, and 7, and they go so on for the four variable truth table. It will go until 15, 0 to 15, 1, 1, 1, 1. Yeah, right. Now how do you so these variables, for some particular function, for some particular expression, they'll have some output O. Okay, x, 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 x's. Yeah, and how we'll fill these x's into the truth table would be according to these values. See, 0, 0, 0, 0. What does this correspond to? This cell, 0, 0, 0, 0, and it has some x. Yeah, you fill in x, whatever the value of x is, 0 or 1. Now how that went was 0. The value of this well, not the value, the address of this cell would be now this one: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this is 15. Yeah, you can cross check this with these values. See, 1, 1, 1, 1. This cell is 15. This cell is 15. Yeah. Okay, let's move on. Well, that was not such a good diagram. My handwriting's not that good, but here's what the K-map looks like. We already saw that. Moving on, we have the visualization of the K-map. Well, K-map, since it was a table, it was a rectangle, right? It can be folded, it can be rolled, so you'll need this in order to make groups we'll be learning about in the future. Yeah, it can be folded, it can be rolled, it can be folded upside down, left side, right. The four corners, they can be joined together. Yeah, and it's basically like this. It's a loop on all the sides. Yeah. Look at this would be the perfect example. See, these dots, you see these are connected over here, and it's a folded ring, it's a rolled ring. It's connected on both the sides and it's rolled. So now we shall revise the K-map simplification process, right? So there were no zeros allowed. Okay, well, in the SOP form. Yeah. Basically no zeros allowed. That would actually just help you to not get confused when you're grouping ones. Alright, so yeah, there are no diagonals allowed, only power of 2 number of cells in each group. Yeah, so there can be no odd number of cells grouped, and group should no odd numbers, and even if it's even, it should be in the power of 2 to the power whatever the cell. Yeah, everyone must be in at least one group. There must be a group for each min term or max term. So there's overlapping allowed, there's wrapping allowed, and fewest number of groups possible are to be made. So we have to cover maximum number of minterms or maxterms in fewest number of groups. All right, I'll just show you once again how that looked like. So this is your K map, some variable x, y, w, z. All right, and that's how it went. 0 0 0 1 1 1 1 0 0 0 0 1 1 1 and 1 0. The table, yeah. Okay, so when we are to make groups, when we are to fill in the value of the expression, the Boolean expression, we'll only be filling ones and not zeros. It's just for our ease. Let's take an example, 1 1 1. We don't want a 0 here, or we'll confuse it with 1 and we might make a quadrant out of it. All right, we don't want a 0 here. So there are no diagonals allowed. This is totally wrong. Okay, we can make groups like this, we can make groups like this. Overlapping is allowed. This one can be overlapped, and if you have a 1 here, it's not like you leave it, you have to group it. Let it be alone, you have to group it. Okay, only 2 to the power n number of cells groups we have to make. So this group was 2 to the power 1, that was 2 cells. This group was 2 to the power 0, that is 1 cell. We cannot make like 3 of this combined, like 1 1 1. We cannot do this. This is wrong. We could have done this 4. This would make a quadrant. We can do this. We can make a pair, we can make a quadrant. If there were 1 1 1 1, we could have made a octet. All right. Yeah, overlappings allowed. Everyone must be in at least one group. Groups should be as large as possible. If you're getting an octet, you make an octet. If you're getting a quadrant, you make a quadrant. Don't make pairs. Make the largest group possible. And
now I will talk about some properties of K-map. N variable K-map has 2 to the power n cells with n variable truth table value. Adjacent cells differ in only one bit. Each cell refers to a minterm or a max term. For minterm, max term, and don't care of f, we place 1, 0 or x. Advantages of using K-map. First, data representation simplicity. Changes in neighboring variables are easily displayed. Changes easy and convenient to implement. Reduces the cost and quantity of logical gates. The Karnaugh map reduces the need of extensible calculation by taking advantage of humans' pattern recognition capabilities. Explain about different techniques to optimize Boolean expression. First, sum of products. Now, let's say we have given this truth table with 3 variables a, b, c and output y. Now we know that minterms is always written when output is high. So we can also represent this truth table as in terms of minterms. Now m0 is high, so we write 0. m2 is high, so we write 2. But m4, m5 is not high, so we didn't consider them. For SOP, if input is 0, then we take complement. Now to represent output, we can see that when m0 is high, input are A0, B0 and C0. So correspondingly we write them, and in OR gate we take with A0 B C0 plus A0 B C plus A B C0 plus A B C. That's all for SOP form. Second technique for optimization Boolean expression is POS, which stands for product of sum. Now for this truth table we have 3 variables a, b, c. Now we can also write this truth table in terms of max terms, and we know that max terms is always written when output is low. Like m0 is low, so that's why we mention 1 and hence 4 and 5. Now for POS, if input is 1, then we take complement. For example, in this C is 1, so we take C complement. Now to represent Y in POS form, we need to take sum of A plus B plus C complement and product of these three terms, which are A complement plus B complement plus C and A complement plus B complement plus C complement. That's POS form. Okay.
Start.
So here I am going to show you how to construct K-map. So we need minterms to construct K-map. So we have here a question which has a minterm 2, 3, 6 and 7. Now we are going to construct two table of these minterms. We have three variables in this question. So write x, y, z and output. The inputs of these will be 2 raised to 8. So we have 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. So now we have the minterms 2, 3, 6 and 7. Now what we'll do is we'll find the binary value of 2. So how can we find the binary value of 2? I'll show you. The simplest way to find the binary value. We have the number 2. Now to find the binary value, let's write the numbers 1, 2, 4, 8. Now we have 2. Now the binary value of 2 will be 0, 1, 0, 0. So here we found the binary value of 2, which is 0, 1, 0. Now we will see where is 0, 1, 0 in this truth table. Here there are 0, 0, 0, so this is not equal to 0, 1, 0. So now we will find the binary value of 2 in this truth table. So 0, 1, 0, which is here, we found 0, 1, 0, so we will write 1 in the output. Now we have 3. Now 3 will be 0, 1, 1. This is 2, this is 3. Now we will find 0, 1, 1 in this truth table, which is here 0, 1, 1, 1. Now 6, which is 1, 1, 0, 6. Now where is 1, 1, 0? 1, 1, 0 is here. So we'll write 1. Now we'll find 7, which is 1, 1, 1, 7. Now 1, 1, 1 is here. Now rest of the terms we'll write 0. 0, 0, 0. Now we have the truth table of these minterms. We don't need this. So now finally we are going to make K-map. So we are going to make the K-map of 3 variables. So now we'll construct K-map using this truth table. So we'll need x, y and z. So we'll have 0, 0, 0, 1, 1, 0 and 1, 1. You write it?
यही रहता है ना. हाँ.
So 0, 1. So now we can see 0, 1, 0, we have output 1. So we'll see where is 0, 1, 0 here. We can see 0, 1, 0 is here, so we'll write 1. Now we can see there is 0, 1, 1, we have the output 1. So 0, 1, 1, we'll write 1 here. 1, 1, 0, 1, 1, 0 and 1, 1, 1. The output is 1. So write 1 here. Rest others are 0. So this is the easiest way to find K-map. The K-map of these minterms is this. This is the final equation. Now I'll show you a different example with 4 variables. Now let's show another example with 4 variables. So now we will write W, X, Y, Z. We'll make a K-map of that. So 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. So we are making K-map, and this order is very important. So please follow this order for making the K-map. So now we have 0, 1, 5, 7, 8, 10, 14 and 15 in our midterms. We'll find the same here. 0 is 0, 0, 0, 0, so we'll write 1 here. 1 is 0, 0, 0, 1. 5 is 5, which will be 1, 2, 4, 8. So 5 will be 1, 0, 1, 0. So we'll have to find the same here, 0, 1, 0, 1, 0, 1, 0, 1, which will be here. 7, to find 7, which will be this, 0, which will be 0, 1, 1, 1. So 0, 1, 1, 1 is here. Then 8, 8 is 8, 0, 0, 0, which will be 1, 0, 0, 0. Now 10 is 1, 0, 1, 0, which will be here. Now 14, which is 1, 1, 1, 0, which will be 1, 1, 1, 0. So 1, 1, 1, 0 is here. Now 15 will be 1, 1, 1, 1. So 15 is all ones, which is here. 0, 0, 0, 0, 0. So this is the K-map. No, 0, 0, 0. So this is the K-map of this question with.
But
So pause this video and try the question yourself. The D here is the don't care terms. If you don't know this, I'll show you after you try it out. So now we are going to solve this question which has don't care. So we have midterms 3, 5, 6, 7 and the don't care terms 10, 11, 12 and so on. Now what are don't care terms? The don't care terms are the terms that we don't care. Yeah, I'm serious, that we don't even care. So the terms like 10, 11, 12, they can be anything. 1, 0, we don't care about them. So we'll write X instead of 1 or 0 in the K-map. So now we are going to construct the K-map for this question. So the same notation as we used in the last question, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So we have 3 as our midterm, which is 1, 2, 4, 0, 1, 1. So we can find 0, 0, 1, 1, which is 0, 0, 1, 1 here. So we have 3 here. 5, which is 1, 0, 1, 0, 0, 1, 0, 1, which we can find it here. So we'll write 1 here. 6, which is 0, 1, 1, 0. So here we can find 0, 1, 1, 0 here. And 7. 7 will be 0, 1, 1, 1, which is here. 0, 1, 1, 1, which will be here. Now the don't care terms. The don't care terms are 10, 11, 12. So 10 will be 1, 0, 1, 0. So now we'll have to just find 1, 0, 1, 0, which is here. We'll write X. 11, which should be 1011, which is here, x. Now 12, which will be 1100. So 1100 is here, so we'll write x here. 13, which is 1101, so we'll write it here. 1101, which is here. Now 14. 14 is 1110. So now we can find 1110 here, so we'll write x here. Now 15, last don't care term, which is 1111. So we can find 1111 here, so we'll write x here. So all the rest terms will be 0, 0, 0, 0, 0 and 0. So here we are. This is the final step and we have found the K-map of this question. So the rules for the grouping are, we'll have to cover all the ones in the groups, and all the groups should have 2 to the power n numbers. So the group may start like this. So first group will be this one, which has 2 to the power n, which is 2. Now second group will be this one, third group will be this one, the fourth one will be this one, fifth one will be this, and the sixth group will be this. So this K-map will have 6 groups, which can be helped to form the simplified Boolean expression. Now we will solve the third question that we have solved earlier. So now to group these, we'll have to also consider the don't care terms. So now in this, all the ones should be covered and the group should have maximum possible grouping. Now for this, the first group will be this one, the second group will be this one, the third group will be this one. Now in this question we only have 3 groups, this will help us to find the simplified Boolean expression.
How to simplify K-maps. We have to group all the ones present in the K-map in such a way that every group should contain 2 to the power n elements. Okay, and then every group should have maximum number of elements. Group can be made in wraparound type. We will learn about that. Number of groups should be minimum. And then group should be as large as possible. Okay. And now let's take an example. For example, A, B, 0, 1, 0, 1. Okay. If we are taking 1, 1, 0, 0, this can be a group. Okay. If we are taking 0, 1, 1, 1, 1, 0. Okay. Okay. For example, this. these this group is not allowed as it is containing three elements and we have to take 2 to the power n elements, that is 1, 2, 4, etc. So what we can do here is we can remove this. We can make a group of these two and these two. Okay, now this is proper as each box is containing two elements. Now let's take an example. If it's like this, let's take an example like this 1, 1, 1. So we can't make a group this because it is having 5 elements. So what we can do here is, or we can't take even this group because 3 zeros are there. So what we can do is can make a group of this 4 and this 2. Okay, now let's take another example of 4 elements. A map containing 4 elements. Okay, now let's take an example like this. Now like this is a group and we can make a group this also. It's like we are wrapping around the table such that this will come under this if this row will be under this. Now here we are making two groups, one this and one this. Okay, here in this this Karnaugh map we can't make a group like this two, this two, and then this two. Because what is happening if we can make a group of maximum elements, here we are making of 4 elements, then it's very good. Hence we are taking this big group. Can show it clearly. This group. This is the best as it is containing 4 elements and then it is all, and this as it is containing 2 elements. Now what we can do is we can take an example. Let's take a summation of 1, 3, 7, 9, 11. This is function of EC. Now this is like we can make the Karnaugh map here. Now 1 is 0, 0, 0, 1. 3 is 0, 0, 1, 1. 7 is 0, triple 1. 9 is 1, 0, 0, 1, 0. Now what we can do is we can take this wrap around and one this and another two. We can't take all the 3 ones at a time as because we can't take 3 elements in a group. We can take only 2 to the power n elements. So now how we are writing the simplified form. Now for this we are having AB as 0, 0 and here AB as 1, 0. So here 0 is common in B. So this will become B bar, and then here C is 0 and D is 1, common for both. Hence it will become B bar, C bar, D. First group is over. Then we can write plus. Now we will proceed to next group. Here what is common? A is common. A with the 0, hence A bar. Now C and D are common, both 1, then C, D, then plus for this group. Here B is common, then B, and here C and D is common, then C, D. This is the simplified form of this expression. So it's very easy to find the simplified form using K-maps. Now let's take this example. Summation of 0, 1, 4, 5, 6, 7, 10, 11, 12, 13, 14 and 15. Now we can make the Karnaugh map here. So 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. And now 0 is this 0, this is 1, this is 4, this is 5, this is 6, 7, 10, 11, 12, 13, 14 and 15. Rest other are 0. Now here we can see that there are many options available. Now what we can see here is the largest group, this we can make is of 8 members. Now what we can do for these leftover ones, we have to cover all the ones present. So we can make this 2 as a group, but we will not make that as it is not containing the maximum number of elements. We can make this of 4 elements and this for 4 elements. Now we can write the simplified form for this big box. What we can do is here B is common. Just a second. Here this B is common, then B. And for this big box, nothing is common in CD. So one for big box it is B. Now for this box, we are having A bar as common and C bar is common. Here we can see C bar is common and D is not common. And for this we are having A common, and here as we can see C is common. So this is the simplified form for this Karnaugh map.
Hello everyone, today I'm going to be teaching you about the don't care condition in K-maps. We use this condition when we do not care about its outcome and denote it with the letter X. It can either be 1 or 0 depending upon the question. Now for example, in the binary coded decimal, we only care about the numbers 0 to 9, and therefore do not care about the numbers from 10 to 15. Therefore, we'll mark them with the letter X. I'll show you guys what I mean using an example. Here we have three variables, A, B and C, and these are the numbers which we'll use. I'll just make the K-map right now. Zero, 2, 6 and 7, and for the don't care conditions we have 1 and 3. 1 and 3. The remaining terms are 0. Now we can either keep the x 0 or 1. If we keep the x as 0, if x is equal to 0, we'll pair the ones like this. This will give us A bar C bar plus AB. However, if we keep the x 1, if x is equal to 1, we can pair these 4 terms and these 4 terms together. And with this we'll end up with A bar plus B. Now we can clearly see that the second condition is more concise and easier than the first condition. This is an example of using the K-map to simplify an equation and come up with a better answer. So we'll go with this answer. Here's another example, and this time I'll be doing one with 4 variables. So the don't care conditions. Just put the values in the table. Now, in order to simplify this K-map, we can pair this like this. We can pair this, and this has nothing to be paired with, so we'll just keep it as it is. And this will give us the equation BCD bar plus AC bar D plus B bar CD plus A bar, B bar, C bar, D bar. Here we can see that the don't care variables don't help us since they can't be paired with any of the remaining x's. This is paired with this, 11 is paired with 3, 13 is paired with 9, and 0 remains as it is since it can't be paired with anything else. Now, it's not always necessary that all the conditions should be either 1 or 0 at the same time. For example, we have 5, 7, 9, 11, 13 and 4. That will be and 2, 6, 10, 12 and 15 as the don't care conditions. Here and here. Now here we can pair this question like this. We can pair these two like this, and we can pair this remaining one either like this, or like this. Now this would result in WZ plus XZ plus WZ plus WY. Here we can see that these three conditions are 0 and only these two are 1. Therefore, it's not necessary that all of the don't care conditions be either 1 or 0 at the same time. If these three conditions are 1, it'll only make our task larger and make the equation more complex.